How's it going, everyone? Welcome. Eliar Gonzalez here, and today we're going to explore now this RxDS, which is a library that is built around the observables. This idea that how can we now deal data that comes over time, right? So when when the source of event, or AKA the event source now, whatever event source is, it can be is the user inputs, so clicking, typing key up, or from the server sending in streams of data. So how can we now deal with all of this different data, single unit of data, and apply some sort of steps so we can distribute that across our system? And that is something interesting because this is a piece of the more bigger pie when we talk about its asynchronicity. So the TLD of asynchronicity here is that, particularly in the JavaScript, is we need to find a way of how can we now write applications to handle is the concurrency in our apps. All of these tasks that overlaps at a time. So because of that, and JavaScript is a single thread language that allows us to write is line of code, and it's going to evaluate those statements one after the another. Okay, so that's great for building is applications, but for distributed computing or for handling events in our case that come from different source of data, well, how can we now do that? What are the tools that we need to use to help us cover some of these particular issues? So we look at callbacks, and it is trade-off that now is a representation of how can we now defer some computations over a period of time after an X amount of time. I want you to evaluate this set of statements. So we have callbacks, the trade-off, which is they are not reasonable, and they now have this inversion control. And also we have to manage is time for ourselves, how things help us with time complexity, or in other words, to eliminate time as a concerning factor, which is a very hard things to do. And then how we look now at the promise, which is this tool that was developed in another language, programming E, made by one of the TC39 members, the TC39 commit members, Mark Miller, among other peers. Sorry if I don't recall them. And then with promise, we have now solved the inversion control problems, and how this is now an abstraction or a tool that allows to represent natively in the language how we're going to now deal with this concurrency. Or in other words, it's an idea around that we want to eliminate time as a concerning factor wrapping around a value, and how we have all of these different abstractions along the way. So because of that, and then we need in JavaScript another tool to actually help us to recreate a very tedious behavior like state machines. So now generators come here and say, hey, this is the way of, this is a syntactic form of how you can describe state machines in your JavaScript code. This also this comes from Python, so it lands now in the language. So now generators is this ability to pause and resume the function execution, because functions by default, anytime you call them, it runs to completion. And it doesn't mean that it won't run any other function inside of that. It means that anytime you call those functions inside of that function, you're going to add to the call stack. So to check, hey, this is the line of code that I'm currently evaluating that, right? And this is the purpose of the call stack. And then once that function has been evaluated, you remove out of the call stack, you pop out of the call stack, and then continue to evaluate where you were before calling that function, or in this case, after you calling that function. Now, then, by looking at how you can create generators and what is the behavior that we want to simulate or recreate, in this case, with the state machines, and how we can do that behind or before that with callbacks and iterators, and what iterators are, which is a way to stepping through typically a data set. So in our case, we're stepping through a control flow, which is a great thing. And now when we create our generators, it returns us a iterator where we can have now the ability to pause and resume, as well as pass message to that. So it acts as a message passenger. And this is not interesting for generators, or for, as the name suggests, is generate or yield values out of this, but also for dealing is with asynchronicity, because one of the problems that generators solve is this non-reasonable problem, non-sequential, non-reasonable problem. Because now we can make sure that anytime we write async operations using is the generators or async and await, what happened behind the scenes is, especially with generators, is once you call that functions, these iterators access through that function execution, JavaScript evaluate that until they find a yield keyword, and then pass control to whatever to whoever called that iterator, okay? Pass the message. In our case, we pass that to the promise, and when that promise is resolved, then you're going to now call the generators with the value, and now resume the execution of that generators. And this is a cycle that you can do over and over and over. And this is quite powerful because this is the next level of competency in JavaScript. So JavaScript developers must know how to use their tools together. And then we explore a little bit more of what a promise is, especially from the when it comes from, or where it comes from, which is from this programming language called E, and how now, because this is also a functional paradigm, the promise are now monads, and I'm gonna dive deep into much to this, but I just want to mention that because these are functional concepts, we need to actually explore in other videos how now the functional programming works, or at least what is the value proposition of functional programming. And then we're gonna see is the how-to. So that's great, that's good. Then we now ask ourselves is that how can we handle is this streams of data, these events that comes at a time from an event source, how can we get which one of them and pass through some series of steps so we can distribute that. In previous videos, for example, like yesterday, I described that how can we now think about this observable by looking is at the Lucy show. Lucy show a back pressure, say back pressure, okay? And I think this is a very interesting video. So the point of this is to see that with back pressures, we are now able is to, well, in this case, wrapping up candies and do that in a way that we can now, when each one of those candies came, we can apply some step here, some transformation here, and then distribute that to the systems. So with RxJS, okay, and then things started to speed up here. It's like, hey, wait, why is all of this? So then how can we now handle is these things, all right? That's for another video. That's known as back pressure, and that's what stream actually is provide us. This is more interesting from the Node.js course, but again, here we are is just on the JavaScript, and especially with RGX, because right now we don't have natively support of observables or these abstractions. We can use some of these libraries that help us to deal with this kind of situations. And now we're going to see a more practical approach of observables, especially from UI developers. And how can we now is take a look at the RxJS. What is the value proposition of this? This was created by SmartFalls at Microsoft, where initially was made in Java, and then pour that to another programming language like Python, C#, and now we have that on JavaScript. This might end up being the last version or the final versions of RxJS, and I'm saying that because this library or this API still continue in a flux state. So we're looking here at RxJS because this is something that is now it's gonna be used as the foundations that at some point in JavaScript we're gonna see that natively. Yes, so let's go to see how we can create an observables. What is the value proposition of observables and how to test them, all right? And then we're gonna see how we can manipulate data and time. So you can think of the RxJS as this load-for events, this helper function that allows you to now work with objects and arrays and with functional programming. But in this case, it allows us to create now this abstraction or this observable, all right? That unlike a promise where it's an eventual value, so it promise fires only once and resolve only once. We need now an abstraction or an idea. We need to have something that help us here is to deal is with series of eventual values. So that is observables. And how now with observables? Well, let's go to look at the most common use cases here. And one of the reason why you might be employable as a UI engineering is that your API doesn't work as expected. And then you need is to support that in your UI. So you create or you have to do a bunch of Ruby Golder machines in order to get that UI in place. Oh man. Oh man, that's a lot. That's a lot. So this observable, we start from the basics with off and from, and how can we use off and from. What is the subtle difference between both of them? So off is for primitive values and objects, all right? But when you need to actually work with series of eventual values, from is when you want to use that. So we can use now here arrays or iterators. So for example, generators is another one. Iterators, generators, array-like, and observables in itself. And here is quite interesting, you know. And then we also look at how can we now start to listen for this errors, right? Or values. So, because in our subscribe, this is the old way of doing this. So we have the value, and then we pass now is we pass now callback functions. All right. So you have now passed the first argument is the value, and the second is the error, and the last is the complete. I think that is not a good maintainable way to do stuff, especially if you want to pass data to that. And that's one of the reasons why they now changed that to, hey, instead of passing me callbacks here, pass me as an object, bro. Pass me as an object that contains now this shape. Next, error incomplete, right? So it makes a lot of sense. So here we started to create our own observables, right? I made a very our first code here. You actually look at that. You can check out the commit here. And again, this is a course from Steve Kinney, so he made that. So we can actually explore more about what is this observable stuff. And how so far we have creating is now synchronous observable, right? So with off and promise. And when we use subscribe, you are creating now is a new instance of that. So if you say now an observable here, what the French stuff is this? You have now an observable, okay? Observable like observable RxJS, and we explore a little bit more the pull versus push, observables as generalizations of functions, anatomy of an observable, creating observables, exactly, anatomy of an observable, okay. Observables are creating using new observable, or a creation operator. Exactly. And, okay, so you can create now an observable using the new keyword. And for those who are not familiar with new keyword, is this now from EX6, if I write, that now this is just function construction. This is now a way of how we can create now objects here, using the new keyword, and how we, instead of, for example, in classes, when we define is the constructor for that, with our function constructor, we just only define is the shape of the data using this keyword. And then it's going to generate now an object based on this function constructor. So you can create an observable this with observable itself, okay, which is a representation. And I want to make a quick pause here before dive deep into the topic, because this is the key of software engineering. And Grady Butch eloquently mentioned, hey, the software computer or the history of software engineering is the history of a layer of abstractions. And let me actually make, I want to, Jesus, because what he mentioned is, by the way, shout out to the Pragmatic Engineering, shout out to you, this YouTube video, because what he mentioned here is something that are crucial for us, those who develop and how those who create and elaborate now software or work on the software industry. It's important to understand how do we get here, and especially what is this all about, right? So that's what we have here. Oh my God!
Well, history of software engineering is one of rising levels of abstraction.
If one of rising level of abstractions. So this is one of rising level of abstractions. is a representation of something that we need to handle here. As I mentioned before about the observable, is that, hey, what is the way of thinking, what is the model that we need to actually represent is this eventual, a series of eventual values, get that one of them, and then do some sort of transformation, apply this series of steps, and then distribute that. Again, very narrow specific to that. Similar with data structure is like, hey, how can we think in ways to actually tell the computers and for ourselves to organize data in a way that is effective and efficient for the machines, and also that is easy to grasp as humans. And now with all of these large language models, where they want to see what is the next, or most company actually want to see or integrate what is this LLM after all, and figuring out what is the best use case for them and how they can solve a particularly specific business problem with this technology. Okay, and that's why a lot of people actually now are deeping into this, and making some explorations and all that kind of stuff. So this is a very interesting exploration and understanding of the observables. So we just want to again recap that because it won't hurt, and then finally jump into the observables.
The entire history of software engineering is one of rising levels of abstraction. So what we're seeing here is the rise of another level of abstractions, which gives us all these extraordinarily powerful frameworks from which I can build systems, in which, as I alluded to, the architectural decisions that were front and center for us back then are now embodied in these. So now it becomes a decision: what cloud service do I use? What messaging system do I use? What platform do I use? That's the decision which has a lot of economic decisions and not just software kinds of decisions associated with it. So I think the role of the architect, in effect, has changed, because now I'm dealing with systemic problems, not just software problems.
Wonderful. And yeah, it's very eloquent there. It's very, very eloquent. Now, well, so yeah, I didn't merge this. All right, good. So let's get into this. So what we really care about this. So we can create now observables, the anatomy of observables, or you can create now an observable from an operator. Are subscribed to with an observer. Execute. Observables are created using the new observables or a creation operator. Are subscribed to with an observer. Execute to deliver next error and complete notification, right? On the observer, and their execution may be disposed. Very subtle, interesting stuff. You can create that using the new operator, the new observables, or with an operators, and are subscribed to an observer, and then execute to deliver next error and complete. Once you subscribe, so notification to the observer, and their execution may be disposed. So core observable concerns: creating observables, subscribing to observables, executing observables, and then disposing observables. Very, very, very interesting. So, so let's jump into a particular exercise we're gonna do here by creating our custom logic observables. Let's get into
The
this.
questions that we got earlier were a little bit more about how observables work under the hood, like what is the thing that triggers next and complete, so on and so forth.
Let me actually go with
The
this.
first one, again, these are
Okay, let's actually go through the exercise, which is in fact, what is this, bro? Follow me. That's right. There you got it. Okie dokie. And well, okay, good. So here we are. Let's get into now the creating observables. And here we say, hey, exercise creating observables. Your mission is to create observable using auth, subscribe to it, putting the values into the result arrays, and get the expected below to pass. So in this case, you say, hey, it should create a new observable out of a single value. You say, hey, well, we can now create an observable with the new observable object, or by just using one of the operators. So we say, hey, the way how we define observables here is following is this convention. Say, hey, put a identifier called observable followed by a $. Hey, this is an observable. And we say off, we're creating a new operator, a new observable. And hey, I want you to now match to the expected result, which is 1. So this is just to define the observable. So you create observables, and then you need is to subscribe to the observable. So here's when you create now a new instance of this. You say, hey, observable, then you subscribe to this, okay? So you're creating a new instance of this eventual value, in this case, only 1. And you're gonna pass now an object here. So you can, as we look in other videos, how you can now subscribe to that. All right. So whether is by using is the arrow function. So you say, hey, this is now a value like this. Say, hey, this value here. I was going to explore a little bit the this one and say, hey, I want to now push the value as it is, right? But I want to dive deep a little bit on the, it's because we don't have is, we don't have is, we just only have is this. Oh, look at this. They're using is, look at this. This is using now the functional prototype, bro. They are using is now, this is the function constructor, function observable subscribe, and then all the prototype, which is adding all of these methods to this place, all right? Oh my God. And they're using now a prototype for that. Good. Well, I just want to take a look now at the subscribe here. Exactly, the subscribe method. As you can see, we can pass is now an observer or next, okay, an error or complete, right? So this is the 3 argument that this can accept. And here you say, hey, subscriber, or you create a new save subscriber, and then his operator.call, this is subscribe, and try to subscribe. Anyway, so this is the magic that happened behind the scenes. And if we run this, for example, you say, hey, I want to say, hey, skip this, remove the skip, and say npm run test, right? And you say, hey, one of them is skip, but we actually solve this problem as it is. So this is one way to now subscribe to those observables. And the other is, hey, because we want is to match this, okay? So it should take a series of objects, as argument and create an observable. We can say, hey, good. So I want to create a new observable. I was gonna go with off in this case. All right, because again, this works for creating observables here. Observable with primitive and objects. So we can say, hey, this is all of the object that I want you to now emit. Okay, followed by comma. And when we subscribe to this observable, okay, so we to consume these streams of eventual values, I can say, hey, I can pass an object here where you say, instead of passing a function, because we are doing is just the happy path, that is, hey, the value, right? On the, no, let me actually explore the yes. Exactly, it's going to explore this overview, observable observer subscriptions, but is from subscribe. And okay. No, give me now an observable here. Flow values. That's quite interesting. How can I map filter just everywhere? But how you can now? Again, take a look at that. Creating, subscribing to observables. Exactly. Disposable observable execution. And unsubscribe. Wow, the observables, anatomy and observable. Wow, okay. Now that you got it. Here you got it. Okay, an example of here. You can define an object with next, error, and complete. So that's what that's one. Okay, that's exactly what I want to take a look. Wait, what? You know, so for example, like this. All right, and here we say, well, on the because I don't know the API, on next. Okay, so on next value, I just want is to get that value, say value, all right, on next value, and then any value that we get here, any streams of data we get here, in our case, objects, I want to know is append that to, or push that, add it to the end of these collections, all of these values, right? And then now, once that is done, when we skip this, say, hey, skip this, run this, it actually passed as expected. The same for now, if we want to do is with generators, okay? Because here with generators, we're going to use is now from, okay? Yeah, from, like so. Hey, we got another test here. you should take an array of objects as arguments and create an observable. And well, this is pretty much here, but in this case, because we are working with arrays and then generators, we use now from that. We say, hey, I want to create now is this, and I can copy and paste this, right? Hey, I want you to now is create is an observable with this collection of data. All of these are static data, and then assign that to a identifier called observable. So good. So this is now observables, and then I want to subscribe to the observable, all right? And I want to make is the using now or passing now the option here by saying, hey, on next, okay, it is next, yes. So on next, get me that value, and well, this is the step that we want you to do anytime you receive a new value. Push that into our result array, right? And then let's go to now skip this, right? And there you got it, right? It actually worked as expected. And then we look now at the generators as well. So there's some subtle stuff here because generator is only going to work until only the yield values, not the return value. So that's something very interesting here. It means that let's go to create now a new observable for the values generator, but because we needed to create now a generator that it return us an iterator. Okay, I want to now is assign that to a identifier called observables, and then now, well, subscribe to that, and we're gonna assume now the happy path for this again by saying is, well, this is next the value, right? And well, I want to take all of those values and pass that to and push them to the data structure here, right? You say result. So once we remove this skip here, and it actually works as expected. One thing to actually look at this is that the return value is not considered here in our observables. Is not considered here in our observable.
Yes. And be in charge of knowing exactly what to do with those values. Seems is great and wonderful.
So creating observables here. Creating observables here. Seeing observables. And now, yeah, creating observables. You can say is basic operators here with our observable here. That's right. Basic operators with observables, and then we have now is examples of that. Creating observables with of and from. Okay.
It is manipulating those streams and playing around with time that becomes a little bit more interesting, and that's where like we can have an infinite generator but say we only want values in a certain case up to a certain extent, skipping this many values. A lot of times your generator, if it was quote unquote infinite, needs some stopping mechanism, like your for loops, right? Otherwise you end up with an infinite loop. You try to iterate over it. Basically, an observable allows you to take out the difference between generating values, that can be the generator's job, knowing when to start and stop, it becomes the observable's job, and we have a separation of concerns. And I will show out the different, if it was quote unquote infinite, needs some stopping mechanism, like your for loops, right? Otherwise you end up with an infinite loop. You try to iterate over it. Basically, an observable allows you to take out the difference between generating values. That can be the generator's job. Knowing when to start and stop, it becomes the observable's job, and we have a separation of concerns. And I will show you some code in a little bit that will basically, we'll see a generator that has a stopping condition. We'll see a generator that goes infinite. We'll then use observables to create the starting and stopping as well. Which means that you can then use the same generator multiple places throughout your application, and then let the observables, the different observables you're using in different places, be in charge of knowing exactly what to do with those values as they go through. All right, so then we have those asynchronous issues. Here we have one where we'll deal with a promise. So here we have Jest done function, which allows us to tell Jest when to actually check everything. So you can kind of go through here and
because this is a Node
it's
a Node 16.
We've done that like 3 times. We get it. But also knowing when it's completed, because it's when the test is completed that we need to actually check to see if the results of the array are what we think they are. So here's a promise, result is 1. We should see that result in an array. Let's go ahead.
Okay, this is another one. Is that the creating observable with order from for single values. So if we go down deep into this, this is now a promise, okay? As you can see here, this is the way how do you now test is observables with promise-like, okay? So again, here because we say, hey, this is now a promise, we're gonna handle that using the front for that, which is the promise, okay? And I want you to assign that to an identifier called observables $. So by the time you now subscribe to this, since now this is a promise, so JavaScript will evaluate all of this set of instructions, and then the event loop kick up with whatever you pass to the call micro task queue, which has more priority than the callback queue. And then you now can have access to this value. So let's go with the happy path here, which is, hey, I get this value, and on this value, oh no, this is a very interesting case because here you can say, hey, instead of actually now defining this as an arrow function, we're going to use the object where you say, hey, this is the next, you got the value here, right? And I want to now, whatever value that you get it, please push that into the result array, right? You can also call is complete. I think is complete, right? Exactly, I think it's complete. So we can now see if everything is done. Say, hey, complete, right? So once we evaluate this promise, or in this case this test, we're gonna say, hey, complete, right? But in this case it failed because we're passing is now a promise here, and it say, hey, expected the result to equal is not as it is. So expected -3, receive +1. Okay, interesting. Creating observables from, and should create an observable from a promise. That's right. Exactly, because we're just actually passing is this, and then we're going to subscribe to this value, right? So it say now that this is the value that we're getting, even though here we can use hey complete and print the result. Okay, and say hey complete with 1. All right, but here it say hey expect the result to equal 1, and it say hey I failed because even though that I get in that at some point here that's quite interesting. That's very, very, very interesting that he failed with that. Okay. So it means that that's quite interesting.
Because basically we subscribe to the promise went on the event loop, right?
So the promise went to the event
Test
loop.
went to see if there's anything in the array. Nothing there yet. Check, the test failed, and then the thing got put in the array, right? So in this case, what we want to do is we want...
Which is what happened here exactly here. So the test failed because JavaScript evaluated this first. Okay. So JavaScript evaluated this first, and then
right? Then the test went to see if there's anything in the array. Nothing there yet.
Exactly. So the test want to see if something is in there. There's nothing in there.
Check, the test failed. And then
check, the test failed, and then
subscribe to... Should probably unskip it if we'd like to fail. But we'll run in this case, and it's going to fail because nothing got put into the array yet, because basically we subscribe to the promise.
Because basically we subscribe to the promise. Basically we subscribe to the promise. The promise went to the event loops.
Right. Then the test went to see if there's anything.
And this is quite interesting to describe that, right? So this is now evaluating a promise. The promise went to the event loops. The test went to see if there's anything in the array. It's not. It's empty. Exactly. The test wants to see if anything. The test wants to see if there's anything in the array. If not, it's empty. And then.
In the array, nothing there yet. Check.
Exactly. There's nothing
Test
yet
failed,
there.
Then
Then check the test failed, and then the thing I put in right.
Right. So in this case, what we want to do is we want to wait until the observable has been completed. So here we'll say next. We'll put the value in. And then when it completes, that's when we'll go through.
Okay, but it's because all of this inner mechanism here. In an observable, you say, hey, the promise went through the event loops, the test evaluate. I'm going to write it down there. Absolutely. Exactly. We're getting observable with off and from for array and iterables and generators, which is great. Okay, which is absolutely great. You can just go back to this. Okay, good. Get status here. With a message when you say it's like, hey, creating observable exercise sync and async for that. Basic operator observables, and this is basic. Exactly. So observables for arrays, iterables, and generators. Observables for single values, arrays, iterators, and generators. Right? Take it, push origin to the feed sync. That's right. There you got it. And when it comes to this one, is this, because now this went through the observable. So
If there's anything in the array, it's going to fail because nothing got put into the array yet, because basically we subscribe to the promise.
so if we trying to evaluate, if we're trying to evaluate promise, like if we try to evaluate promise here,
The promise went on the event loop, or we'll run in this case, and it's going to fail because nothing got put into the array yet, because basically we subscribe to the promise.
If we try to evaluate promise with observables and test it, okay, our test will fail because our promise, we subscribe to the promise, so our test will fail because we subscribe to the promise. It is passed. Exactly. We subscribe to the promise. It is passed to the event loop. It is passed to the micro task on the event loop. It is passed to the micro task on the event loop. Just evaluate the code. So just evaluate your test.
The promise went on the event loop, right? Then the test went to see if there's anything in the.
Then the test went to see if there's anything in the array. Okay, just want to see if there anything on the. So yeah, our test. In this case, our test want to see if there's anything on the array. It's not.
Right. Nothing there yet.
Exactly. There is nothing yet there. There is nothing there yet. There is nothing yet there.
Check the test.
There is nothing there yet. Check, the test failed. Check, the test failed. Check, the test failed, and then exactly check, the test failed, and then put the value on the array. And then put the thing in the array.
Test failed, and then the thing got put in the array. Right. So in this case, what we want.
So, and I think this is quite interesting to evaluate because now we have a little bit more vocabulary to describe and how. Yeah, there is a lot of vocabulary to that. That's right, my friend. That's right. Oops, no. Observable for single values are arrays, iterables, and generators. Exactly. Which is this. So, quite interesting. So far so good, no problem with that. However, when we are dealing with asynchronicity, okay, which is, hey, with observables, we are now using its promise, and it's going to subscribe to the promise. It passes to the event loops, or test, evaluate, or test run, okay, or test one to see if there's anything in the array. It checks that exactly, or test one to say is there anything there. There is nothing there yet. It checks that the test failed, and then put the value on the array, because again, this instruction is going to be evaluated first, and then whatever is on the callback here, and then whatever is on the event loop. So because of that, we say, hey, on complete, okay, I want to say, hey, now for our test, I want to actually is run this code, right? So behind the scenes is now handling is, or we're passing is this set of instruction. In this case, the expect is passing now this expect. The result is passing now this function, okay, to the call stack. Might be is passing now these functions to the event loop, and once that is done, now I want you to solve is this. Again, this is for synchronous promise, right? For series of synchronous promise. Dot to be, or to not to equal the result, in this case d1, right?
What we want to do is we want to wait until the observable has been completed. So here we'll say next, we'll put the value in, and then when it completes, that's when we'll go through, expect everything, and then tell Jess that we're all done in this case. So run it again. Right, now it passes. Right, so there's nothing synchronous or asynchronous about observables, and we'll see a little bonus section at the very end, like how exactly. Right, now it passes. Right, so there's nothing synchronous or asynchronous about observables, and we'll see a little bonus section at the very end, like how exactly this might work under the hood.
Okay.
But in the case of asynchronous ones, just have to treat them that way.
Okay. Okay. How this thing works behind the scenes.
All right, so what happens when a promise rejects? So the nice part about from is that it, when you give it a promise, will kind of wire itself up to all of the kind of accoutrements of promises in this case. So what we can do is, what happens when a promise rejects? What do we use to find that error? Catch. Right? And so basically, when it resolves, we get a next value. When it catches, it emits an error value, right? And then it completes. A observable made directly from a promise is very similar to a promise. It resolves, it rejects, and then it completes. Why is this useful? Because you can imagine a world where somewhere in observable, we might want to make an API request, right? And being able to then get that back into the stream is super helpful for us. So we'll go ahead and we will kind of try this out. Able to, then it completes. Why, right? And then it completes.
So we'll get into catching errors in a greater detail, but this is a good opportunity to see how to respond to an error in this case, a reject promise in our
A
observables.
observable made, well, we might want to make an and we will kind of try this out. So here we have a promise that immediately checks, and so what we'll do in this case is we need to say observable in this case, and it will be from this promise, which is not going to go well. And in this case, we will
Is to subscribe to that, but on the error.
And this one's never going to give us an X value. You could prepare for the happy path, but like this is a pretty straightforward promise. It's going to reject. That's all it knows how to do is reject.
Yeah, this is a pretty straightforward
so in this
reject
case, we
promise.
have an error situation. Now, the thing about errors with observables is error is effectively a completion state as well, right? When an observable encounters an error, it's done. It unsubscribes, game over, right? So we can actually put our done logic in this case in the error as well. So this time, instead of getting nothing like complete, we'll at least get a copy of the error. And so here we will go ahead and we'll grab our test logic. Awesome. One of the questions that we got earlier were a little bit more about how observables work under the hood, like what is the thing that triggers next and complete, so on and so forth. So I wrote one additional bonus test, which is we're going to kind of like write our own observable in this case with our own logic and kind of see.
Is to actually write our own observable here. So it's pretty much here the same with reject, but now in this case we're gonna create now a we're gonna create a observables by passing a promise that is pretty straightforward, that is gonna fail, just to test this to see that works. Call it as an observable and put it now $sign because this is a convention, and then we say, hey, observable, right? I want to now subscribe, but in this case not to the value, which is the next value, but to the error here, right? So this is now a function that we pass here in an object where we say, hey, I would like to now expect the error. We're gonna get the error here. I expect the error here to equal to the message here that we're passing here, right? So far so good, and that'll be all, by the way, especially when you are now is running tests in asynchronous mode. So if you now skip this, no, and then you is to run the test. Let me actually not show in this. I'm gonna do that. Not at all here. Oh, because we didn't pass is the done. This is to indicate to our test, hey, yes, evaluate, and then it's done, to tell the test runner. Okay. That's quite interesting. And there is a bonus here on creating observables.
Kind of different pieces of an observable. A lot of times, like, you will just kind of either, we're basing it off of things that happen. We're taking a promise and turning it into an observable. We are taking events. I think about making your own bespoke observable a lot like when you use the promise constructor to write your own promise. Does it happen? Occasionally. Does it happen often? Nope. Right, and that is very much the case about constructing a new promise or a new observable as well, is most of the time you don't need to do it. Well, let's show you how just in case. So we go here, and here we can go ahead and say, make our observable.
To create an
And we'll say
observable.
new observable.
Exactly.
And you know how when you make a new promise, it's a new promise that takes a resolve and a reject? Not dissimilar.
But in this case, it's now
subscriber.
a subscriber function. The executor here. The function, the executor. Which is something that we look at this. The observable is this one. So you got now they're creating another over here, which is the subscribe function you're gonna pass there. So like promise, what you pass now, this function called the executor, and now the function that you pass to observables is a subscribe.
You can name it whatever you want, but that is what the TypeScript IntelliSense will suggest it. And in here, you can write all of our custom logic around how this observable should work. So we could say subscriber.next John.
To actually generate all of this value similar like an iterator.
George.
And as you can see, this actually follows the same pattern as it is. Well, you can see that,
and
but you will
because we're doing this one by hand and not using of or from, we are in charge of telling the observable when it has completed, right? So this one would say, instead of like return in the generator that we saw before, which is simply say subscriber.complete, and that doesn't take any values. And this is effectively very similar to that generator that we saw as well. The important thing to note is we've seen now synchronous observables and asynchronous observables, right? This is a synchronous one because when we create the new observable, it's just going to run through.
It's going to go run through all of
We'll
this.
kind of play around with some of this in a second just to get a sense of it, but it's going to run this line of code. It's just it's normal JavaScript. There's nothing particularly special until you were to put like a set timeout in there. Well then, yeah, right? Like that would have it would become an asynchronous one. We'll take a look at this in a second. Let's just make sure this test passed before we play around with it any more than that. Great, and now it passes. So the interesting part here is also, with promises, for instance. Once a promise resolves, that's it, right? The promise has resolved. That's how I feel about New Year's resolution. Same thing is true with an observable. Once it completes, we'll never get to this line of code. It's almost the same thing as like a return statement in a function, right? Once you get to that complete, it is game over. We'll never add Ringo to the Beatles, which is sad, but that's the example. So this test will now fail because it's running. Yeah, it fails because Ringo has been kicked out. So we'll minus sign, Ringo's not in there. Because we've already completed, we closed the observable stream, it is over at this point. So if we were to throw an error, anything that would happen after that error, if we didn't catch it, would also complete the observable as well. So this is how you can kind of write a bespoke observable if you need to. If you have some kind of custom logic that of or from whatever doesn't work for you, this will do the trick.
But this is to create your own custom events. All right. Okay, that's quite something. That's very interesting, and that'll be also is for today's video. As it is. Let me actually get rid of this. Right, and let's say, hey, git add. That's right. And then git commit with a message, which is now promises, resolve and reject, resolve and reject promises, right? Stop. Say git push origin to feed sync. There you got it. And that'll be all for this video. Take care. Bye bye.